So we're going to have a little elementary school fun trying to set up and use the milliamp readings inside the meter for DC. So what we're going to do first, before we hook it up for milliamps, we're going to mess with an LED. So I'm going to first select ohms, and we're going to measure ohms of this resistor, this dropping resistor, and then we're going to measure the forward drop of this red LED. So the resistor is 500.7.8.9 ohms, kilo ohms. It's 0.5 kilo ohms. If we change the range to ohms, it's too low of a range. It was 200, sorry. Meg, 20 meg, 200. That's 200 ohms. So I guess that's the best range we're going to get, is reading 0.5. So then we're going to change the selection to where it says volts. And the breadboard is set up with the cathode of the LED, in the pin, the minus rail of the breadboard. So we're going to look for the forward voltage drop of this LED, 1.8328, roughly is what this says. Okay, so with those measurements, we kind of put a predictive circuit together. Let's see what it looks like. So at these different volts, we should see different milliamps with that resistance and that LED forward drop. And there's going to be a little bit of error in it because it depended when it measured it. It may change the last digit or something on the reading. And the other thing that we neglected, the forward drop of the IR drop of the LED. So that may have a little impact too, but we're going to have some fun and see if we can measure milliamps. So for this demonstration, what we have wired up is we have a power supply, and luckily that power supply also has a reading for milliamps, and we're going to see how the meter lines up with that milliamp display. So for the LED, I modified the circuit. See if we can see it here, where we come in with the voltage from the power supply, goes through the milliamp meter, through the resistor, through the LED, back to common. So it's coming, the yellow wire is coming through out of the power supply in to the milliamp input of the meter. They're coming out of the milliamp input through the common out to the positive lead of the circuit going to the resistor right there. Through the perf board, the resistor is connected to the LED, and the LED has this common point connected through the jumper back to the power supply. So what we should see is the different voltages come up. We should see the milliamps change and see how close they are to calculate it and see how close the meters agree with them. So the meters on it's set for 3 volts, and we're supposed to see 2.33 milliamps. Okay, so the milliamp meter over here is doing a little bit better of a job. It's 2.157. This is 0.002, so this has much greater accuracy here on this one for reading that. And we can see the LED is a little bit lit, and that's 2 milliamps worth. So if we crank it up to 5 volts, we should see 6.3.25 milliamps approximately. So I'm going to have to change the power supply over here to 5 volts. And at 5 volts, this is saying about 5 milliamps. This is about 5.5. So we predicted with the calculation it was going to be 6.325. We may have a low voltage drop here on the meter, and we neglected to put the LED IR drop in the formula. So that's okay, but it's pretty cool. We're close. We're within 10%. So we're going to keep going. At 10 volts, we should see about 16 milliamps. So we're going to crank the voltage up to 10 volts. Okay, the milliamp meter on the power supply is saying 0.014, 0.015. So it roughly is agreeing with this 15.25 milliamps. Milliamps are a little bit lower than what we expected, but we had thrown out a couple of variables, so that's actually lining up pretty good. And then at 15 volts, the calculated current is 26.31, so we'll crank it up to 15. And lo and behold, the calculated value is 26.31, and here we're about 25 on milliamps on this meter, and the milliamp meter on the power supply is agreeing with it pretty closely. It's saying 0.024. It doesn't have the resolution to show us more detail. So this is actually pretty good experience to show where the milliamp meter is. One of the things you could use it for, and it actually does a pretty good job. And here's our LED. We can see that it's glowing quite a bit brighter now. So to have some fun, the range on this milliamp selection on the input is about 200 milliamps. So I didn't calculate what that 200 milliamps is going to be on voltage, but I thought maybe what we do is just keep turning up the voltage and see what happens to this LED and the current. So there's 20 volts. There's 25 volts. You see the LED's burning pretty bright. I don't know what the LED's rating is, but usually they're 20 to 40 milliamps. It's at 40 right now. We're 30 volts on the power supply, and it's still there. The resistor's getting a little toasty, and we're at 50 milliamps on the LED. Everything's hanging in there. I was hoping we were going to burn the LED out.